All right, welcome back. Today we're going to start into more counting principles and how to find basic probability. But before we start, I kind of want to review last time. That will kind of make things all put back together. Because remember, on our fifth lesson, we're going to be doing nothing but probability problems. And it's vitally important to understand this stuff before we get to there so we can clearly make out what we're doing. Now, we learned how to count last class. We learned how to figure out different number of items in certain situations. The very first thing we talked about was the fundamental counting principle, and that's basically to get the total number of combinations, we just multiply the numbers together, right? So if we were looking at license plate numbers here, and this is for Kentucky, remember, if you wanted to know the total possible number of combinations for a Kentucky license plate, all you do is figure out how many numbers go in each space and then multiply them all together. Well, remember, Kentucky license plates are a total of, I think it's 3 numbers followed by 3 letters. Am I correct? Does anyone know that? Because I'm Ohio. Either way, it's either 3 numbers and 3 letters or 3 letters and 3 numbers. So all you do is you count the total number of possibilities within each blank. So if we're talking about numbers, we're talking about 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 digits. So that's a total of 10 possible things starting with 0. And so you just multiply them all together, and then there's 26 letters. That's how we can get the total number of combinations. Now, there are special circumstances. And one of them that I did not go over with you last class that I want to go over with you because it wasn't in your notes is with or without replacement. Have you all ever heard of that before? That means this. With or without placement, do you see how I put 10, 10, 10 here because there's 10 total digits? That means I can reuse the same digits over and over again. So if I used 3 here, I could also use 3 here, and I can also use 3 here, right? That means that I have replaced my 3 over and over again. I have an unlimited amount of 3s to be able to put into here. That's with or without replacement. Sometimes you aren't able to replace, and you have to know what the question's asking yourself. Let's talk about lottery. I know we're at Christian school, so we don't ever play the lottery. But what are the possibilities for the number of combinations for lottery, right? Let me ask you something. Let's say there's 60 questions to choose from. 60 numbers to choose from in the lottery. If you choose a 1 for the first time, are you going to be able to choose a 1 again? No. Once that 1's been chosen, it doesn't get replaced. So now we have 59 numbers because we've taken out the 1. Now we have 58 numbers because we've taken out that. Now we have 57 numbers, and then you multiply those together. And if you keep going on and on and on, that's where we get the factorial. That's 8, or in this case, it'd be 60 factorial, right? That's 60 times 59 times 58. That's different than this up here because this is with replacement, and this is without replacement. Okay, so those are the different scenarios you have to ask yourself. Am I allowed to reuse the numbers? Am I not allowed to reuse the numbers? That's the factorial. And then we talked about the difference between permutations and combinations where order matters, order doesn't matter. Okay, so those are the different ways that we can count our possibilities. Are we going to be able just to put out our blanks and figure out how many's in each one? Are we going to have to do this, this, or this? Okay, so that's where we went last time. Let's talk about today. Let me go to our classroom. Let's go to Algebra 2. Let's go to classwork. Let's go to probability. So today's lesson is actually pretty easy. And I think you all will enjoy this pretty much. So we're going to open this up in a new tab. We're going to download our answers. All right, my friends. Okay. All right, so we're going to find theoretical probabilities. These are actually easy probabilities to find and experimental probabilities of an event. So there's a lot of things that we're going to talk about today. We're not going to get into the weeds on all these, but there's some words that we're going to throw out today as we go through here. What is probability? Probability is the measure of how likely an event is going to occur. Each possible result of a probability experiment situation is an outcome. The sample space is a set of all possible outcomes. An event is an outcome or set of outcomes. So when we're talking about probability, we have these things that we're going to be thinking about. The sample space is a set of all possible outcomes. That's the total number of ways that this could happen. Remember, with our lottery situation, we were figuring out the total possible combinations of the different numbers that could come up, and their license plate number, we could come out with the total possible number of license plates there are. That's the sample. An event is an outcome or set of outcomes that actually is occurring. So we have to know that it's kind of like a test. You have the total possible points on the bottom, and on the top you will have your what you've gotten correct, and that's how you're going to get your probability. So for example, if we were rolling a number cube, and each one had a number on its face, we have a sample space of either rolling a 1, a 2, a 3, a 4, a 5, or a 6. If we were spinning a spinner, and this is what the spinner looked like, we would have a total possible sample space of red, blue, green, or yellow. Probabilities are written as fractions or decimals from 0 to 1, or percents from 0% to 100%. The closer you are to 100%, the more likely that probability is to occur. Closer to 0, impossible. So here is exactly the theoretical probability formula that I've been talking about over and over again. Equally likely outcomes have the same chance of occurring when you toss a fair coin. Heads and tails are equally likely outcomes. Favorable outcomes are outcomes in a specified event. For equally likely outcomes, the theoretical probability event is the ratio of the number of favorable outcomes to the total number of outcomes. Basically, it's the number of outcomes in your sample space, and then on the top is going to be what you're trying to figure out per the question. What is the number of favorable outcomes? And we're going to do some examples to show you, but it's basically a division problem. If you boil it down to it, probability is division. On top of the equation is what you're trying to find. On the bottom of the fraction is the total number of samples outcomes in your sample space. So for example, each letter of the word probable is written on a separate card. The cards are placed face down and mixed up. What is the probability that a randomly selected card has a consonant? So here's how you would do this. First off, how many total letters are there? There are 8 possible outcomes. You could pull up a P, an R, an O, a B, a B, an L, an E. There's 8 possible outcomes. How many are consonants? 5. You have a P, R, B, and L. There's 5 things it's what's asking. So all you have to do is put it into a fraction, 5 divided by 8, which is 62.5% when you put that in your calculator. Example here, 2 number cubes are rolled. What is the probability that the difference between the two numbers is 4? The difference between the two numbers is 4. Well, there are 36 possible outcomes. How did we get that? We rolled 2 number cubes. Each cube has 6 choices. 6 times 6 is 36. So we have to figure out how many rolls have a difference of 4. So what is the number of outcomes with a difference of 4? Really, you have to kind of know your situation. You could have a 1-1, a 1-2, a 1-3, a 1-4, a 1-5, or a 1-6. So you have to look at this and figure out which ones are going to subtract to equal 4. We have 1-5, 2-6, 5-1, and 6-2. So you have 4 divided by 36, which is 1/9. So there's some examples for you in your packet. I want to go over the practice problems, but you have plenty of examples there to look at. I don't believe we have any complements. Let me see here. Find the probability. Yeah, I don't believe we have any complements in your homework, so we're not going to talk about a complement. Yeah, I believe this is basically yeah. So let's now go to your practice problem so you can see what kind of stuff I'm going to be asking you to do. I'm actually going to use my document camera because I want to. All right, so this stuff's a piece of cake. I think you guys will get done with this real quickly. The first type of stuff I'm going to ask you to do is represent the sample space that we're using in set notation and words. So you have a new car is available in red, white, green, and black. What is the sample space for this? Well, we have options red, white, green, and black. So that's what we're going to circle. That's our total possible sample space. A coffee shop offers French roast and Italian roast. What's our sample space? We literally only have two choices, French roast or Italian roast. Am I going too fast, or is this as common sense as that? Okay. A pizza stand offers hand-tossed, pan, and thin crust. How many options are there? There's three, hand-tossed, pan, and thin crust. When a computer button is pressed, a computer program outputs a random even number, greater than 0 and less than 12. You press the button once. What's our total choices? Remember, it's even, and it's greater than 0, less than 12. So we have 2, 4, 6, 8, 10. Now, I'm asking you the same thing, but instead of telling me in words what they are, you're just telling me how many there are. So when a button is pressed, a computer program outputs a random even number greater than 0 and less than 10. You press the button once. Well, what are the total possible outcomes? 2, 4, 6, 8. How many things are there? 4. That's what you're doing. You're just counting how many things are in your sample space. So super easy. A sandwich shop has 3 types of sandwiches, ham, turkey, and chicken. How many things would be in your sample space? 3. I mean, it's not tough. A football player attempts a pass in overtime. The pass attempt can result in a completion, an incompletion, or a turnover. How many choices are there? 3. Now, the last few, all you're going to do is come up with the probability by doing basic probabilities things. On the bottom of the fraction will be your sample space, which you just spent time finding. And on the top would be our desired outcomes we want. So a bag contains 3 yellow tennis balls numbered 1 to 3. The bag also contains 3 green tennis balls numbered 1 to 3. You randomly pick a tennis ball. It is yellow or has an even number. First off, what's our total sample space? I'm sorry? 6. Our total, a bag contains how many balls here? 3 yellow, and the bag also contains 3 green. Do you all see how there's 6 things in the bag? Okay, now we have to figure out of those 6 things, and if this helps you visualize it, you don't have to do this for every one, but I have a yellow one numbered 1. I have a yellow one numbered 2. I have a yellow one numbered 3. I have a green one numbered 1, a green one numbered 2, and a green one numbered 3. So what you're doing here is you got to figure out what number's going on the top. You randomly pick a tennis ball. What is the probability that it's yellow or has an even number? I'm going to circle all the yellow ones and all the ones with an even number. How many did I circle? 4. So my desired outcome is 4. I have a total number of 6. That reduces to 2/3, which is why your answer is A. Does that make sense? Okay. A bag contains 3 yellow tickets numbered 1 to 3. The bag also contains 5 green tickets numbered 1 to 5. What's our total bottom of the fraction, our total sample space? What would you say? 8, because there's 8 tickets in there. There's 3 yellows and there's 5 green. What is our desired outcome? You randomly pick a ticket. It is green or has a number greater than 2. How many green ones do we have there? So we know there's at least 5. How many of the yellow tickets are greater than 2? See how I did that? 6/8 or 3/4, which is why we get our answer as that. And last but not least, you roll a fair 6-sided die. The die shows an even number or a number less than 6. Let's go ahead and write our total sample space. How many things are on a die? How many choices are there's 6? Okay. The die shows an even number or a number less than 6. So the numbers are 1, 2, 3, 4, 5, and 6. First off, it shows an even number. Well, let me circle all the even numbers. Or a number less than 6. Aren't 1, 3, and 5 all less than 6? So literally, we have 6 choices divided by 6 possible outcomes. Therefore, our number is 1 or 100%. Guys, that's how we do basic probability. That's how we figure out our sample spaces. As we get into higher up probability, we're going to have to take our permutations and combinations to be able to get our numerator and be able to get our denominator. And that is where probability can get a little more complex. So that's it for today. I hope you all enjoyed it and you find it easy. I did 10 problems for you and taught the lesson in 15 minutes. I think you can do 20 questions on your own. And if you have any questions, please feel free to reach out or ask me